Okay, we're gonna begin here. So let's see where we're at. So I asked you guys the other day, well, for the last couple days, so make sure that you've done 11, 19, and 20. So again, our goal today is just to go over that. I'm just gonna go over those normally. Obviously, ask questions as you need to ask them. And let's just go from there. Whoops. Hopefully we're still connected. I think we are. I think I just accidentally clicked on somebody. Okay. So let's get going on here. So the first one is asking us to find. So let's see. We got this continuous function defined by these graphs from -4 to 3, and there's 2 quarter circles and a line segment. And then we are given this. So as always, the first thing that we need to do is we need to look at the graph and determine what are we looking at, right? And in this case, we're looking at the graph of f. So we're looking at this piece right here, right? Which it is a velocity function, but it's not a velocity function for g of x. I think you guys would agree. It's kind of like a piece of it. So just kind of recognize what we're seeing. We're just looking at this piece right here, nothing else. That's what the graph is showing us. Okay? So, with that being said, let's see what we can do. So the first thing we're asked to do is we are asked to find g of -3. So in other words, I'm going to take wherever I have x, I'm going to plug in -3. So this becomes 2 times -3 plus the integral from 0 to -3 of f of t dt. So let's just start from there, because that's kind of the big concept there. Obviously, there's more to it, but that's the big concept there. So see if you have any questions just for that first part. And again, I'm looking in the questions and information channel of Discord, or of course you can ask in the live stream itself. Either way is fine. Or of course, if you want to jump in the general voice channel. Okay, there does not seem to be any questions, so let's go through and evaluate. So let's see what we got here. So 2 times -3 is -6. I'm going to switch my limits of integration. So remember, in order to switch those limits of integration, why is that so huge? I don't need that to be so huge. So in order to switch those limits of integration, I'll remind you that we got to change the sign. So this is positive. It's now going to be negative. F of t dt. Okay? Then from there, let's see what we got. So I get -6 minus, now I've got to go evaluate this. And reminder, I need to evaluate this using the graph. And I am about to sneeze. I will turn away so I don't hurt your ears, but just be aware of it if I take off for a second, because I'm going to sneeze. Okay, let's see what we got here. So we are supposed to find, we're going to find the area underneath the curve from -3 to 0. So in other words, we're going to go and find this piece. So I think you guys would agree that's just the area of that quarter circle. And that quarter circle is, what is that? So that is 1/4 pi r squared. R is 1, 2, 3. So 3 squared. So we end up with -6. Looks like -9/4 pi. In regards to question A, see if you have any questions. Okay, let's keep on going then. Let's go to B. So what is B asking? I'm sorry. What's the second part of A asking? So we're not going on B. We're going on the second part of A. So the second part of A is asking us to find g prime of 3. So in order to find g prime of 3, the first thing I'm going to go find is I'm going to go find what is g prime of x. So I'm going to go take the derivative of our original function, right? So I'm going to go take the derivative of this. Okay. And again, in regards to the concept that I'm going to be doing here, is everybody okay with this? Okay, then let's keep on going here. So let's go take the derivative here. So the derivative of 2x is 2. And then using the second fundamental theorem, we get f of x. So then when I go to evaluate this at -3, I get this. Was -3, right? Yes. And then f of -3 is, going to the graph, f of -3 is 0. So we get this equals 2 plus 0, or 2. In regards to letter B, do you have any questions? Sorry, I keep on saying letter B. In regards to the second part of letter A, do you have any questions? Excuse me. Okay, then let's keep on going here. I'm going to erase a couple things here, and I'm going to get rid of this so I have room to work. Okay, so let's go to B now. What do we got with B? Determine the x-coordinate of the point at which g has an absolute maximum on the interval from -4 to 3. Justify your answer. Okay, absolute maximum. So let's think about absolute maximums. How do we find them? Okay, absolute maximums occur either at the endpoints or at critical points. Those are the only locations that you can have an absolute maximum or absolute minimum. So in other words, I'm going to need to do a couple things. One, I'm going to need to figure out what is g of -4. What is g of, I'm going to just put it here for now because I'm going to probably rearrange it a little bit, g of 3. And then finally, what is g of any, I'm going to put down critical numbers. Okay, so I don't know how many critical numbers I'm going to have, so I'm just going to put critical numbers for here. That's what I'm going to have to go do. I'm going to go find my critical numbers. I'm going to go evaluate g of -4, g of 3, and then g of those critical numbers. Whichever one of those is the, was it maximum? Yep. Whichever one of those is the largest, that's my guy. Okay? In regards to the concept, before we actually get going on the actual math for this one, are there any questions? Okay, then let's go and do it. So I'm going to, you know what? I'm going to start with just finding the critical number first, and then I'll go do my evaluation. I think that's the way I'd like to do this. I mean, it doesn't matter, but that's what I'm going to do. So let's go find the critical numbers. So critical numbers occur where the derivative is undefined, or should I say that where the function is not differentiable, or where it equals 0. So I'm going to set this function equal to 0. So I'm going to set this function equal to 0. And there's a question in the Discord, but I'll take care of it in just 1 second. So I'm going to be setting g of x equal to 0. In other words, I'm going to say 0 equals, sorry, I'm not going to be setting g of x equal to 0. I'm going to be setting, let me try that one more time. I'm going to be setting g prime of x equal to 0. Okay? So before I continue here, let me just take care of some of this question. So why can't you just look at the graph? I'm assuming you're asking about, and I please clarify if I'm wrong, but I'm assuming you're asking about why can't I look at the graph and say, oh, look right here, this is the highest point. So, the point 0, whatever that is, 3 is the highest. But remember, they're asking about the minimum, they're asking about the maximum of G, and this is the graph of F. Was that what you're asking? Looks like it is. Okay, so, and nicely done. Good, nice answer there, Katie. Okay, let's see what we got here. What do we got here? So g prime of x equals 0. So the first thing I'm going to do is I'm going to take the derivative of our g of x function, and I think you guys would agree the derivative of that function, which we've already did. I think we did it when we did a. So we got the derivative of g prime of x, and let me just do that real quick. G prime of x equals 2 plus the derivative of f of t, so we get f of x. Okay, we already did that in the last one, so that should still be good. And then I'm going to set that equal to 0. So I'm going to say 2 plus f of x. Okay, so before I continue, let's see if there's any questions. Looks like there is a question coming in right now. Okay, so the question is, so Zia asked, but doesn't g of x equal 2 plus fx, which is true. So would they be similar? They are similar, but they're not the same. And here's what I mean. When I go to solve this, I think you would agree, critical numbers occur when f of x equals -2. Okay, so normally, right? Normally we'd be looking at, so yes, are they similar? Absolutely, they are similar. But in terms of our solve, that's what our solve is going to give us. So in other words, if I were to draw a line at -2, a horizontal line at -2, wherever the graph of f crosses that line, that's my critical number. So I think you guys would agree in this case, I have a critical number right here, whatever that point is. Okay? So in other words, I think you guys would agree. So just kind of notice, that's my point. That's where I have one critical number, and it is whatever that value is. Any questions on that? Okay, so at this point, our job is literally just to find this, and you may have different ways that you're going to find it. What I'm going to do, honestly, is I'm just going to write the equation. This is for me. Like I said, you may have a different way of doing it. At this point, it's really just an algebra question. I'm going to go write the equation of the highlighted line, and then I'm just going to figure out when it equals, what did I say, -2. So in other words, that line is, the equation of the red line, well, it has a y-intercept of +3, and its slope is down 6 over 3. Down 6 over 3, so its slope is -2, so it's going to be -2x. So then I'm going to just set it equal to -2. And I get x equals 5/2. So that right there, this point right here, 5/2, whatever, right? Because I don't know what the y value is. Actually, I'm sorry, I do know what the y value is. Why am I saying I don't? It's -2. That's my that x equals negative. That x equals 5/2 is my critical value. Okay. Any questions on how I found the critical value? Okay, then let's go through and evaluate. So I need to know I'm going to take the endpoints, which were g of -4. I'm going to go evaluate g of -4. I'm going to go evaluate g of 3 And then finally, I will evaluate g of 5 halves. Again, whichever of those is the largest, that's my maximum. So g of negative 4, I get, plugging in negative 4, I get 2 times negative 4 plus the integral from 0 to negative 4 of f of t dt. Ooh, excuse me. Which is going to be, looks like I'm going to need a little extra room here. So let me give it to myself. That's going to be negative 8. Again, I'm going to switch my limits of integration. So negative 4 to 4 of f of t dt, which is going to be negative 8 minus, whoops, I see it. Okay, so let's see here. So in other words, in this case, I have to go find the area underneath these two circles, these quarter circles. One of them is negative, right? The little one has a negative value because it's below the x-axis. The other one is above the x-axis. It has a positive. So the one that's below the x-axis, sorry, I'm going to have to keep on kind of flipping up and down here. So it is 1/4 times pi r squared. I'm going to make the 1/4 in this case negative because it is, I want to make sure that that area is negative. And it is pi r squared where r is 1. So in other words, it's negative 1/4 pi. And then to that, I'm going to add the area for this one. And we did this earlier. We already found it, and we said it was 9 pi over 4. So let's see. Sorry. Okay, so let's see. And that gives us, just to do a quick evaluation here, that's going to be, what is that? That looks like it's negative 8. That's 8 pi, so 2 pi minus 2 pi. Okay? In regards to finding g of negative 4. In regards to finding g of negative 4, see if you have any questions. If not, I'm going to move on to g of 3. So g of 3 in this case is going to, so I'm going to take my function, evaluate 3, so I get 2 times 3 plus the definite integral from 0 to 3 of f of t dt. Okay? And in this case, I got, let's see, let's go back to the graph. Ooh, what a mess. What a mess. Okay, so I'm going to be finding the area underneath the curve from, what did I say, 0 to 3? So 3 is right here. So I'm looking at this stuff, okay? And I think you guys would agree those two triangles are equal. So what I'm going to end up getting is I'm going to get 6 plus 0, okay? Let me just stop. Oops, I'm sorry, I see that I did it for the 5 halves. That's still g of 3. I just put it in the wrong spot. Let me move that out of the way. So, one more time, g of 3 equals 6. See, again, if that makes sense to you, or if you have any follow-up questions on that. Okay, now the last thing I need to do is I need to figure out whether g is 5 halves. So I think you guys would agree. That's going to be 2 times 5 halves plus the integral from 0 to 5 halves of f of t dt. So I keep on scrolling back and forth. So before I do, just make sure that that makes sense to you. It's very similar to what we've been doing. So in this case, I'm going to get 5 plus, and I'm going to have to go and evaluate this. So let's see what we got here. I'm going to have to go and evaluate this thing. So I want to go from 0 to 5 halves. So maybe something that looks like this. And there's again, as always, there's a couple ways of doing this. I'm sure you could do it geometrically. It wouldn't be particularly hard. What I'm going to do, though, is I already found the equation of that line, right? Didn't I find the equation of that line already? So why not just take its definite integral? That's what I'm going to do. Again, you could do it geometrically. I'm just going to go and take this line right here that I've highlighted, and I'm going to evaluate it from 0 to 5 halves, because that will give me exactly what I'm looking for. Okay, so that's what I'm going to do right there. Is I'm going to just take that thing and evaluate it, because it's really easy, and I don't have there's no guesswork involved. Okay, no triangles needed. So I'm going to go and do that. Okay, and so in this case, I get 5 plus, so this becomes, what is that, 3x minus x squared, evaluated from 0 to 5 halves, which is going to be, what is that, 5 plus 15 halves minus 25 fourths minus 0. So this whole thing comes out to, looks like 5 plus 5 fourths. Okay? So at this point, let's just kind of sum up what we've got here. So at this point, what I have is I have g of negative 4 being equal to negative 8 minus 2 pi. I have g of 3 being equal to 6, and I have g of 5 halves, my critical point, being equal to 6 1/4. Okay, so what's my answer? My absolute maximum? That's not how you spell absolute. Okay. See if you have any questions on that. So I think this one was a justification one, and my justification is the work that I did. This part right here, I do want to emphasize, this was completely optional. I was just kind of using it when I'm talking to you guys. The stuff that I did, all this stuff up here, that's my justification. So again, any follow-ups that you have on letter B, since I keep on liking to say letter B, on letter B, apparently my favorite letter. There's a question coming in. Okay, so the question is, how come in all the other problems your work couldn't be the justification? Usually it can. The only times where I have to kind of like write something out, like in like English, is when I'm doing, usually it's an existence theorem. So I'm saying, hey, here's how I know MVT applies, or this sort of stuff. Otherwise, your math is your justification. So, like I said, if you're having to explain something, so how did you know there was a maximum here? Oh, I knew there was a maximum here because it went from increasing to decreasing. That's how I knew. Okay, well that's an explanation thing, because they're asking, how do you know? It's not okay. I wouldn't, don't make a blanket rule as in, so the question is, so only for theorems? No. So again, if I ask you, if I change this problem, I said, how do you know at 5 halves there is a maximum, right? How do you know that? Well, the way I know there's a maximum is I could look to the left of 5 halves, right? And to the right of 5 halves, and I could say, okay, it's, the derivative is increasing, and then it's decreasing, or the derivative's positive, and then the derivative's negative. So it's more of like, when they ask, how do you know? that's kind of my justification here. So, like I said, you just kind of, I don't want to give you a blanket statement that you don't use words, that you do use words. I just want to, I want you to recognize math is words. That is a justification. All the stuff that I did here, that's a justification. What else do I need? You know, in this case, what else is there need? What else needs to be said? I have found my endpoints. I found my critical value. I'm good to go. Another question is coming in. Again, the more you do of these, the more you kind of look and see what they do. You kind of see what to expect, but sometimes there's no way to do it in math. Sometimes I just have to start saying, this is my reasoning. If you were to figure out a value once, for example, 9/4 over pi, no, you don't. So once you have found a value, you can use it. Your work's done. You don't have to keep on, showing over and over and over how you find the same value. So for example, I didn't show how I found 9 pi over 4 because I'd already found it in question A. So absolutely not. Okay, any further questions before we move on to C? Okay, let's move on to C. Wow, that one was kind of a long one. Okay, let's see what we got here. Find the average rate of change. Let me clean up my graph a little bit more. Excuse me. Find the average rate of change on the interval from -4 to 3. There is no point C on that interval for which f prime of C equals that average rate of change. Explain why that statement does not contradict the mean value theorem. Okay, so let's start. There's two questions here. Question number 1 is find the average rate of change on this interval. So they are asking us the average rate of change. Oh wait, did I skip one? Oh, I'm sorry. I did not see C. Okay, excuse me. Let's do C first. Okay. Find all the values on x on the interval from -4 to 3 for which the graph has an inflection point. Give a reason for your answer. Okay, so we are looking for an inflection point for C. Okay, so let's see here. Inflection points, let's think about inflection points. They occur where the derivative function changes from increasing to decreasing, right? We're looking at the second derivative. So in this case, let's look at our slopes of our tangent lines. I think you guys would agree, just kind of visually here, all my slopes of my tangent lines all the way up to x equals 0 are positive, right? And then at x equals 0, all the slopes from to the right of that are all negative because it's one line. So in other words, we have one point of inflection, and that point of inflection is x at x equals 0. My reasoning being is f prime changes from increasing to decreasing at x equals 0. Therefore, x equals 0 is an inflection point. So, couple things I want you to take note on. One, I had to use words here. Why? I had to say, how do I know that's an inflection point? There's no math. They're right. I can't do that mathematically so much is I have to explain my reasoning. Oh, because, this is increasing, this is decreasing. Second, I want to emphasize the words that I'm using here. I'm using the word increasing and decreasing, not positive and negative, right? The reason is the word increasing, decreasing represents a rate of change. I am saying I am looking at the derivative. When I say the rate of, I'm saying I'm looking at the derivative of these things. So I'm saying to the left, all these slopes of tangent lines, all these derivatives are positive. Right there, so therefore they're increasing. So I'm really emphasizing the fact that I'm taking the derivative of f prime, right? So I'm taking the derivative of f prime, and that's what happens when you use the words Excuse me. Nope. I'm taking the derivative of f. Let's rephrase that, because f is the derivative of, is part of a derivative here. Okay, I know that was a little confusing, but I hope that makes sense. What I'm really trying to emphasize here is I can't just say f is positive, f is negative. Because if I'm saying f is positive, f is negative, then I'm talking about the derivative. I'm talking about part of that derivative of g. Instead, I'm talking about the second derivative. Also, I want you guys to notice, and I didn't show it, but I probably should have, right? G double prime of x is going, I'm going to take the second derivative of our function. So just quick reminder, let me kind of backtrack on that work a little bit. I mean, I'm okay in my explanation, but I just want to make sure you guys are okay in your understanding. So we said g prime of x was equal to 2 plus f of x. So g double prime of x, I think you guys would agree, would be equal to 0 plus f prime of x. Okay? Just to make sure we put that connection together. Okay, so let's see. So instead of decreasing, increasing, decreasing, can you say the slopes of the tangent lines change from positive to negative? So I'm really very cautious about using the words slopes. I would rather you use the words increasing, decreasing. Would they take off? I'm not sure. Again, I want to remind you, I kind of think of the word slope when we're talking about derivative as a bad word, as a curse word. So I understand if I want to say, here's a slope of a secant line, from A to B. Yeah, that's fine. That's a good use. But slopes of tangent lines, yeah, that's right. But I'd still be very cautious about using it. I would use the word increasing, decreasing, showing that you are talking about derivatives. Some more questions coming in. I know I haven't finished yet. I still have to answer the question. So I have not finished C yet. If we need the sign chart for f, would we look above and below the x-axis? No, you wouldn't. So if I were going to, let's say I was going to do this, I was going to make a sign chart for this. I'm assuming you're talking about the second derivative. Let's say I was going to make a sign chart for the second derivative, which I could do. So first off, let's see here. I'm going to erase part of this here. If I wanted to make a sign chart, so let's think about what's going on here. So I'm looking at the second derivative. So I've got my remember, this is kind of a derivative function that I'm looking at here, right? When we go to g double prime of x, all we're looking at is the derivative of this function right here. Okay, so derivatives occur where the derivative is 0, right? There are no zeros, but where it's also undefined, and we have a cusp or a corner there. So that right there, we have an issue right there. So at x equals 0 is kind of my inflection point. So I can say for my sign chart, right, there's an issue right there at 0. Okay, now to the left of 0, what's going on? Oh, those things are increasing. So positive. To the right of 0, what's happening? The slopes of the tangent lines, or it's decreasing. So negative, right? So we have an inflection point. Okay, so I could make a sign chart. Again, you can't use a sign chart as part of your justification, but of course for yourself, if that helps, that would be useful. Okay, but again, I'm looking at slopes of tangent lines specifically. Any follow-ups on that before I finish up C? So The question is, but in general, if you have a function of f and you want the sign chart of f double prime, do you look at increasing, decreasing, or above and below the x-axis? And the answer is we're looking at increasing or decreasing when we're talking about a second. When we've got a, if you're given f prime and you're looking and you're trying to determine f double prime, you're looking at increasing and decreasing. Okay, let's continue. Let's continue with C, excuse me. So let me get rid of this. So we were asked to, what were we asked to do? Find all the values, find all the, I guess I did finish up C. I thought I didn't finish up C. Let's see, find all the values. No, C's finished. Okay, I don't know why I thought there was more to C than that. Okay, let's move on to D then. Okay, in regards to D, so what do we got? So remember there was a couple parts to D. One was we had to find the average rate of change on this interval, and then we had to explain why mean value theorem doesn't apply here. So let's start with the average rate of change. So I think you guys would agree the average rate of change for f is going from, -4 to 3 is going to be f of 3 minus f of -4 over 3 minus a -4, right? We're just going to find the slope of the tangent. We're going to find the slope of the line from here to here. And that is going to be equal to -3 plus 1 over 3 plus 4, or -2/7. Okay, step 1, done. I found the average rate of change. Next, why does mean value theorem not apply? So let's think about the requirements for mean value theorem. Requirement number 1, the function has to be continuous. Okay, this function is continuous because by the Mr. Friedman rule that we can never speak of, I never left my pen off this, my iPad when I colored that in. So it is continuous, great. But it's not, there are places where it's not differentiable, right? How do I know? Well, there's a vertical right here. It goes vertical for just a split second. And also, it's not differentiable right there. Also, there's a corner right there. So it's not differentiable there. So mean value theorem does not apply. Why? Because it's not differentiable at the coordinates at x equals -3 and x equals 0. So I'm going to say okay, see if you have any questions on that. So there's a question coming in, a couple of questions coming in. Question 1, when it says explain why the statement does not contradict the mean value theorem, I thought it meant that it does apply. No, so let's see what their statement was. Their statement was there is no point C on the interval from -4 to 3 for which f prime of C is equal to the average rate of change. So it doesn't contradict that statement. So the mean value theorem says if we have a function that's continuous and differentiable, then there has to be a C value on that interval such that f prime of C equals that average rate of change. There is no contradiction here because while the function is continuous, it's not differentiable, and therefore it doesn't it doesn't apply in this situation. We can't use mean value theorem here because that function is not differentiable on that interval. Okay? Next question is, if you only need it to fail at one place, can you just mention x of 0? I would say probably yes. You'd probably get full credit if you just mentioned, hey, look at x equals 0. It's not differentiable. Therefore, mean value theorem doesn't apply. I would think that would be fine. I mean, is it safer to mention both? Yes. But I think as long as you say it's not differentiable, here's how I know, even if it's just at one point, I can't imagine you don't get full credit for that. Again, I'm not grading it, so I'm not going to promise you that, but I think you're good to go. Okay. Katie, Beth, are you both good with with those explanations? Is there any follow-ups on those? Okay, perfect. Then I think that is it for number 11. Let's just, before we leave number 11, is there any general questions regarding number 11 that were missed and need to be taken care of? Okay, if not, let's move on to number 20. Number 20. Whoops. I kind of like that format. I'm going to do that again. Number 20. Okay. Was it 20 or 19? I think it's 19, huh? Let me double check. It was 19. I know it's 19. I say that not knowing it's 19, but I'm pretty sure it's 19. So let me go and grab that. 19 first and 20. Okay, perfect. Yeah, that's what I thought. Let's go here. Let's paste that. Perfect. Okay. Let's see what we got here. So, rocket A has a positive velocity v of t after being launched upward from an initial height of 0 feet at time 0. The velocity of the rocket is recorded from time 0 to 80, as shown in the graph above. So then we got to do all these different things for it. Okay, so as always, the very first thing that we need to do is we need to determine, we're looking at this table. And now that I've got enough people in here, I'm gonna ask this, and let's just do this in the live stream. Let's determine if it's 1, a position, 2, a velocity, 3, an acceleration. So the table that we're looking at, is it a position function, a velocity function, or an acceleration function? So in the live stream, let's just do 1, 2, or 3. Let's see what you guys think. Okay. You guys know. Good. It's absolutely a velocity function, right? Again, I really want to remind you, make sure that's kind of the first thing that you do whenever they give you a graph, a table, a function, or anything. Just make sure, just take a second and say, what is this? Is it a position function? What is this? Because it really changes. If you don't know that, then the rest of the question's just not going to go well. I think you guys would agree. So let's see what we got here. Starting with part A. So find the average acceleration of the rocket over the time interval from 0 to 80. Indicate units of measure. Okay, we're looking at the average acceleration from time 0 to 80. Let's do that. Okay, so we are given a velocity function. So if we're going to find the average acceleration, what we're going to do is we're going to find the slope of the line from time 0. Whoops, I thought I was highlighting. So from time 0, whoa, what the heck? Excuse me. I think I'm zoomed in. Oh, I am zoomed in. Give me 1 second. I need to make this bigger. Much better. Okay, so we're going to go find the slope of the tangent line from time 0 to time 80, okay, of v of t. So in other words, what I'm going to give is the average acceleration is going to be equal to, so let's just write that down. No. Now I can't spell the word average. Average. So it's going to be equal to v of 80 minus v of 0 over 80 minus 0, which I think you guys would agree, that's going to be equal to 49 minus 5 over 80, which is 44 over 80, which equals, again, we don't have to reduce this. You could have actually stopped right there, but I'm going to keep on going. I'm going to get 11 over 20, and our units are feet divided by seconds, or seconds squared. Okay? In regards to letter A, see if you have any questions. A question is coming in. So think about what we do. So the question was asked, I don't understand why that doesn't give the average velocity. So let's just back up for a second here. Let's pretend that I gave you a graph. Okay? And this was like for a runner or something like, and it says distance away from home at specific times. So maybe the graph looks like this. Okay? So these are all position functions. This graph right here is a position function. So I'll call it S of t. When you go find the slope of the line, so for example, when I go find the slope of the line from point A to point B, what I am finding, right? Let's think about what that slope is, right? Those slope values are y2, in order to find the slope, I'd say y2 minus y1 over x2 minus x1. But think about your units. What are you doing? You're taking your position function, so maybe let's say feet, and dividing it by time. Notice your units, right? What are those units? Those are feet divided by time. That's a velocity thing at this point. So in this case, in the question that we were just looking at, what were we doing? We were taking the velocity. Well, in the numerator, our velocity units were, what were our units? Oh, our velocity units were feet per second. That was the numerator of our fraction. What are we dividing it by? We're dividing it by time again, so we're dividing it by seconds again. So this becomes feet per second per second. So we are actually finding the average acceleration, right? And you can just kind of use the units to kind of help you understand that, hopefully. See if that makes sense. Daria, does that clear it up? Remember, whenever you're finding a slope of something, you're finding an average, an average rate of change over a period of time. You're not finding a derivative, you're finding an average rate of change. Okay, hopefully we're good to go there. Any other follow-ups on letter A? I think that was it for A, right? Okay. B, I have a feeling this one is going to be interesting. And the reason I say that is I have a feeling some of you made some mistakes on this one, because there's some common mistakes that when I grow and grade your, the finals and stuff like that, and I have a midpoint one, there's always some mistakes on this. So let's see what we got. Using correct units, explain the meaning of this definite integral in terms of the rocket's flight. Use a midpoint Riemann sum with 3 subintervals. Okay, let's go and do that. First thing is I'm going to go and grab my table just so it's a little bit closer to me. So let me grab this. Okay, and we are doing this from, what did it say? 10 to 70. So we are looking at that. Okay, so we're going to find a Riemann sum. We're going to use a Riemann sum to calculate that. And the sublengths are equal. Okay, so let's see here. I'm going to come up with 3 rectangles. So, and they're going to be evenly divided. So rectangle 1, let's see what we got here. Rectangle 1, I'm going to get rid of the highlight real quick. Okay, so rectangle 1 is going to it's going to go from a base of 10 to a base of 30. I think that is correct. Rectangle 2 is going to start at 30 and go to 50. So rectangle 2, these lines are a little bit confusing, so I hope they make sense to you guys. Let me do it this way. So the first one is going to go from here to here. The second rectangle is going to go from here to here. And then the last rectangle is going to go from here to here, okay? So those are my 3 rectangles. It's sometimes a little bit easier to look at it graphically, but I'm being a little lazy by not looking at it graphically. Okay, so notice each of these, so let's see what we got here. Each of these bases, so the red base, right, goes from 10 to 30, so it's got a base of 20. The green one's got a base of 20, and the last one's got a base of 20, which again, they said they want all the bases to be the same. So we've done that. So if I want to go and evaluate my function, the Riemann sum from 10 to 70, well, that's going to be the sum of all these rectangles. So let's go and add these rectangles up. So each one has a base of 20, so if you guys don't mind, I'm going to take the base and I'm going to multiply it by my 3 heights. Now this right here is the important part and where students make mistakes. We are using the midpoint of each rectangle to determine the height. In other words, I am using these 3 numbers to be the height of each of my rectangles. So in other words, I'm going to be doing f of 20. Sorry, I don't know why I'm saying f. It's v. I'm going to be taking v of 20 plus v of 40 plus v of 60. Again, these are representing the midpoint of each rectangle, and that's how they're asking us to determine the height. What a lot of students do is they try to take the average of the left-hand side and the right-hand side, and that's what they call the midpoint. But literally, what you do when you're finding the midpoint, when you're using midpoint to find, a Riemann sum like this, all you're doing is you're taking the midpoint of each rectangle, and you're using that to determine the height of the rectangle. Okay, before I finish this up, because at this point, it should be pretty easy, see if you have any questions. Okay, so let's go and do this. So this gives me 20 times v of 20 was 22, v of 40 was 35, v of 60 is 44. And did they ask for units or anything? Use correct. Oh, I have to explain the meaning. Okay, so that's my value. Let me just go back. In terms of the rocket's flight, use the midpoint. Okay, so now let's go through and explain this meaning. So the meaning of this is, think about what we did. We just found a displacement, right? A definite integral gives me a displacement. So what I'm going to say is I'm going to say, let me sum up what I'm going to say really quickly, and then I'll write it. So this thing right here represents the total distance traveled from time 10 to time 70. Okay? So so let me write that down, then I'll point out a couple things. So represents, okay. So the only thing that I kind of want to emphasize to you guys when we're discussing this is make sure, don't just say, it represents a displacement. Be specific to the problem. And when I say be specific to the problem, make sure you include in your explanation, those limits. So in this case, it doesn't just represent the total distance traveled. It represents the total distance traveled from A to B, right? From time 10 to time 70. Okay? See if you have any follow-ups on whatever letter this is. What letter am I on? B. Okay, so the question is, how does it represent total distance if you're adding velocity? I'm not adding velocity. Remember what this is. So if I were to graph this, the velocity function right here. So I'm just going to make this up. Please don't. It's not a good representation of what is given. But if I were to graph this, so this is my velocity function and I am graphing it. Here's my graph. Okay? What happens, so this graph represents v of t. When I go find the area underneath the curve, which is what I just did, I am integrating this. So I am going up one. I am looking at a position function. The units in this case, so the question is, what are the units? So let's think about this. Remember, every time we integrate, we divide by our denominator units. So if our original units were feet per second, I'm going to divide by seconds. So in this case, my units are feet. So in this case, whatever this number is right here, which I don't know, it would be feet. Okay? Any other follow-ups in regards to letter B? Okay, let's move on to letter C. Let's move on to letter C. Let's see what we got here. I'm going to need this. I am going to need this. So, not this. I'm going to need this. Okay, what do we got for C? So rocket B is launched forward with an acceleration of that, feet per second at time t equals 0. The initial height of the rocket is 0 feet, and the initial velocity is 2 feet per second. Which of the two rockets is traveling faster at time t equals 80? Okay, so what they're really asking, let's make sure we're okay. We have rocket A, rocket B. So I'm going to say we want to know which velocity. So V of A is going to be, the velocity of rocket A, and V of B is going to represent the velocity of rocket B. And at time 80, which of those is faster? So the first thing I'm going to need to do is I'm going to need to go and find. We already know the velocity for rocket A. For rocket A, I'm going to go to my table real quick. For rocket A, at time 80, the velocity is 49. So at time 80, its velocity is 49, feet per second. Let's go and find the velocity for rocket B. So the velocity of rocket B is going to be equal to, we're going to take the antiderivative of A of t. Okay? So in this case, that is going to be equal to this. Okay, so we're going to integrate this like we normally would. I'm just going to do, let's see, I'm going to let u equal t plus 1, and then so du equals dt. That's nice and easy. I'm also going to pull that 3 out. So I get 3 times the integral and of u to the negative 1/2 du. And that becomes 3 times 2u to the 1/2 plus some c. So this is going to give me 6 times, actually, t plus 1 plus c. Okay, I still need to solve for c, obviously, but that's, whoops, I don't know why I have a 3 there. Okay, so far, see if you have any questions. There's a little bit more to do on this, but there's not a lot. Okay, so let's go and find, questions coming in. Maybe, maybe not. Oh, so the question is, when do you choose the subscript of C1? So I should have actually done it here. And the reason being, I was in terms of U, and then I went in terms of T, and so I'm going to use a different letter. Again, you're never going to be taken off for that. Technically speaking, though, I use C1 when I'm in terms of U, and then I use C when I go back to when I resubstitute. Okay? Again, that's kind of like the minutia stuff. You're never going to get taken off for that, but that's the general rule. Okay? Okay, let's keep on going here. So now, this is our velocity function. We want to find the specific things. So what are we told? We are told at time 0, it has initial height of 0 and initial velocity of 2. So at time 0. So what I'm going to do is I'm going to evaluate this at the point 0, 2, because that's our velocity function. So I get 2 equals 6 times 0 plus 1 plus c, not 6. And that is going to leave me with 2 equals 6 times 1 plus c. So I got negative 4 equals c. Okay? Before I move on, because probably should, are there any questions on finding c? Again, I had to use the velocity value, right? They gave us information about that velocity. Okay, so now our function, our v of t function, is actually going to be, so v of t for this function is going to be 6 times t plus 1 plus c, which is minus 4. Okay, next I'm going to take this function and I'm going to evaluate it at 80, right? So I'm going to evaluate this at 80. You know what I'm going to do, if you guys don't mind? I'm going to put a B here. It's not a big deal. It's just for my explanation part, it'll make things a little bit more understandable. So I'm just going to put a B there because I'm taking this is all for the velocities of function B. So in this case, I get z of 80 plus 1 minus 4, which is 81, so 6 times 9 minus 4. So that gives me 54, 50. Okay, so v of b at 80 equals 50. So now the question is, which of the velocities which of the two rockets is traveling faster at time 80? So I'm going to say V of 80, which equals 49, is less than V of B at 80, which equals, let me move that over, which equals 50. Technically, just so you guys know, I would have been okay saying this. V of A at 80 is less than V of B at 80. I don't need to put those numbers in. I like to put them in just to be kind of like over obvious of what is going on here. But I could have done this because we have those values already, so we're good to go. So the rocket B, my conclusion is rocket, R-O-C-K, rocket B is traveling faster at time t equals 80. Okay? See if you have any questions on that. Okay, then let's move on to 21. Let's move on, or sorry, 20. Excuse me, not 21. Let's move on to 20. And I'm going to go and grab it like I normally do. Okay, let's see what we got here. So first thing we're supposed to do is we are supposed to just kind of do our normal thing and what's it called? Make our slope field. So this is going to take me just a little bit of time. I actually haven't done this yet. So when x equals 0, it's undefined. They didn't give us any of those points. So let's see. Let's start with when y equals 0, we get 1 over 1. So it looks like that. At that's 2 over 1. So it looks like that. And that is when it's negative 1. So it looks like that. It's kind of weird, the points they gave us. At 2, 0, we get 1 over 2, which is 1/2. So maybe like that. And then let's go to negative 1. When x equals negative 1, we get 1 over negative 1, which is negative 1. That's going to be 1 over negative 2. And then 0. And then last, we get negative 2. So that is going to be 1 over negative 2, or negative 1/2. So maybe like that. Okay? My guess is, in terms of the point values, they would probably be giving points for all the positive slopes. So 1 point for all of your positive slopes and 1 point for all your negative slopes. I'm not sure. Maybe something you can look up. So again, I have the correlation thing. I'm not sure exactly how they'd give the points. This would not be worth any more than 2 though. I can't imagine this is worth more than 2 points. Okay? So in regards to the slope field, do you have any questions? Okay, let's go on to the second part here, because this second part is where all the points are basically. So let's see what we got here. We're asked to find a particular solution for y equals f of x. So again, you're going to have to solve for y to the differential equation at the given point at the point negative 1, 1, and then state its domain. So there is a lot going on here. So first thing we are going to have to do, and we have done this always, when we have slope fields, this is always the question. They always ask this, okay? So the first thing we're going to have to do is we're going to have to go and find our function. So we're going to have to integrate this. So using separation of variables, I'm going to get dy over 1 plus y equals dx over x. Before I continue, because this one is a little bit longer and it's kind of involved, so far, do you have any questions in regards to b? It's not terrible, but it is a little bit involved. And I know separation of variables isn't always a strength. Okay, let's integrate. So left-hand side, I think you guys would agree that's a natural log. So I'm going to get the natural log of 1 plus y equals the natural log of the absolute value of x plus some c. Okay? Next, now, before I go on any further, I want to point something out because this line is pretty important. We have natural logs, right? Which means when we talk about natural logs, this thing is there's two situations here, right? There's two situations here. One of the situations is that first off, our natural log values, when we look at its domain, right? The domain of a natural log is greater than 0. That doesn't mean this thing's going to be greater than 0 because notice what could happen is we could have when we go to graph this, and I'm just kind of making this up because we have two natural logs here. When we go to graph this, what's probably going to happen is we're going to have two different branches. And this is completely off. Let's say the graphs kind of look like this. So one branch might look like that. Maybe the other branch looks like this. I have no idea. Okay? We're going to have to choose which branch we're talking about. Because it's a natural log, it can only be one of those two that creates this function. And we're going to have to choose which one it is. Right? So either the domain is going to be x is greater than 0, meaning we're looking at this, or the domain is going to be x is less than 0, and we're looking at that. Okay? So just kind of keep that in mind. It's all because this is a natural log function that we're going to have something like that. We're going to have to make a choice. Which branch are we talking about here? Because natural logs don't have two branches. They have one, right? They only have one. So let's see what we got here. And I know that's a little confusing. It's not, the domain question is not really a lot of points, but that's kind of the explanation on it. Probably would be missed by most students. Okay, let's keep on going here. So let's go and solve this here. Question is coming in though. So the question is, does it matter that one's in terms of x and one? No, it doesn't. Because we're going to put this all in terms of, we're going to write this all in terms of y anyway. So I am not finished in any way, shape, or form. I was pointing out this line because I wanted you to understand that there were going to be two pieces and we had to choose one of them. This line kind of emphasizes. This is kind of, it's always a little bit weird to explain this one, and that's why I'm doing it. Okay, so let's get rid of our natural logs by doing this. So each of these is being done like that. Okay, so in the first one, I'm going to get the absolute value of 1 plus y, and that's going to be equal to, and I just want to kind of emphasize this, it's going to be equal to that. Let's kind of answer that. So the question is asked, but since it's domain, which x values would you choose? Would you choose the one with the x already? Let's kind of hold off on that. Let me go through it and see if you have that same question when I go and make that decision. Because I think it's going to make a little bit more sense when I go and make that decision. I think. Okay? So, from here, I'm going to get 1 plus, well, actually, yeah. No. So, just a quick note, I'm going to let E of C1 equal just some C. So what I'm going to get is I'm going to get 1 plus y equals, I think you guys would agree, this whole thing just evaluates to the absolute value of x, and I'm still multiplying it by some e to c. So now I get 1 plus y equals c times the absolute value of x. Okay? That's just kind of doing the algebra there. See if you have any questions in regards to the algebra. Okay, then next thing we're going to do is we have to find c, and the way we're going to find c is we're going to plug in the given point. They gave us the point -1, 1. So I think you guys would agree. I'd get 1 plus 1 equals c times the absolute value of -1, which means I get 2 equals c. So the question was asked, just really quickly, the question is asked, how did I get rid of the absolute value? I want to remind you, when we get rid of absolute value, so let's take one step back really quickly, and I'm going to do this in red. So let's go from here. I have 1 plus y equals c to the x. I think you guys would agree that that's absolutely true. Why can I get rid of the absolute value? Here's why. So when I normally would break this up, we'd break this up into two things. I break this up into either 1 plus y equals positive c times the absolute value of x, or 1 plus y equals negative c times the absolute value of x, right? That's how we would normally break it up. But remember, positive c, what is that? Well, c can be positive or negative. So this is being really redundant, right? Because c can be positive, it can be negative. So going right to here is fine. Because again, c can be positive or be negative, so there's no reason to break it up into two like that because it's already taken care of by the c itself. I hope that makes sense. Okay? Let's keep on going here. So now if you guys don't, I'm going to plug in my function. So for c, so my function now is 1 plus y equals 2 times the absolute value of x. So y, because they want us to write this as a function of y equals this. Okay? There's one more piece to answer, but there's a question coming in, and we'll take care of that before we finish. Basically, the last question is domain. By the way, the domain question is worth 1 point. Like I said, it's a little bit rough. So the absolute value of x cannot be canceled out because we'd have to be solving for x, which we're not doing. So I would have to solve this for x and then, do the plus or minus. But we're not solving for x, so we can't just get rid of it. Okay? So the last question is, let's talk about domain. So this is our function, but let's think about the point that we plugged in. We plugged in the point -1 or 1. So remember, we plugged in the point -1. And I told you from the beginning, I said we had to make a decision. So, and I said our graph, again, it wasn't accurate, but we had two branches. One branch where x was greater than 0. One branch where, that's terrible. But one branch, that's not a function. That's going to bug me too much. One branch where x was less than 0. We had to make a choice. Well, we plugged in the point x equals -1. So we have to be talking about this branch. So our domain is going to be x is less than 0. So that's my choice, and it's based on the point. Could I have made that decision a lot earlier? Yes. Right? I didn't need this function right here to determine that, but I decided to do it there. Hopefully that makes sense, though. I had to make a choice which branch I'm using. I had to choose the branch that included x equals -1. Again, that's probably a stretch question, I feel. It's a little bit rougher to understand. See if that makes sense to you. And again, at this point, see if letter B makes sense. If there's any follow-up questions on B. My guess, by the way, if you want to kind of see points here, they would be giving probably 1 point for your separation of variables. They would be giving probably a point for this. So they'd be giving a point for that. And then they would be giving another point for your plus C, right? That plus C, especially when we're talking about separation of variables and stuff like that, is really important. Then, let's see, that you solved for C, that you got your equation, and then you stayed your domain. There's probably something else in there because I don't know if we have enough points. What do we got? 1, 2, 3, 4, 5, 6. There's one more point in there somewhere else. I don't know where it would exactly be. Okay, let's see what we got here. So a question here. So with a differential equation, so with a different initial condition like 2, 2, for example, the domain, we would, yes, exactly. So it's all based on the initial condition. And in this case, if 2, 2 would be on the right branch, so we would be saying x is greater than 0. Absolutely correct. Okay? Any other questions that you have? Okay, if not, so Monday we are going to be looking at a brand new problem type. Just so you guys know, as the newer the problems we get, the more concrete they are, the more closer to things you've done before. So this one, when we go to look at it, we're going to be looking at, and I of course will put a summary of it when we get there, but we're going to be looking at, I want to say, number 9. Okay. Which again, it has to do with rate of change. I know that we're not always happy with rate of change problems, but we're going to be looking at a rate of change type problem. And that's what we're going to do for number 9. So at this point, I don't have any free response that I want you guys to do over the weekend. So the only thing at this point that you should be doing, and again, we should be finishing it for Friday, is the calculator multiple choice, right? For that first test. We should be finishing that up because we're going to spend a day, maybe 2, going over questions on that. So Monday again will be on question number 9. Tuesday we'll probably be going over and quickly hitting any questions that you had in regards to the multiple choice on that. Maybe also going over another, free response, maybe another one that's similar to number 9. Okay? So before we leave here, are there any other follow-ups, any questions that you have regarding what we just did or regarding next week? Or questions in general that I can answer? And again, if you don't have any questions, I will see you next week. But I do have some questions coming in. Nope. Okay. Well, again, as always, I thank you guys for your time. This wasn't too long. I thought I was going to go for over an hour and a half. It didn't. It just went for hour and 20 minutes or whatever. Actually, probably even a little less than that. So I'll be throwing it up on YouTube. And I thank you for your time. Let me just make sure that there looks like maybe a question coming in. I'm not sure. Yes. So what I will do, just to make sure that you guys are okay with it. So when I get to Discord, I always post the schedule in the announcement section of Discord. So if you're looking at Discord, I'm trying to find my Discord. So when you go to Discord, I post, that's not you guys, this is you guys. So in the announcement section at top, I will post what you're supposed to do. I'll also post on the website. And this week I will do a much better job about sticking to it. In fact, if there's a day I'm not sticking to it, let me know. So again, I will be doing the announcement section. Okay. So just kind of look there. It'll give you the live stream schedule. Just be aware, I might have to change the live stream schedule times a little bit. I'm starting to get quite a bit of meetings with teachers and stuff like that. I'm trying to not change the live stream schedule for you at all. But just please always look at the schedule ahead of time to make sure that don't just assume 10 a.m. It should be 10 a.m. for the most part, but just please double check it, okay? So thank you again, and I hope you all are doing really well and staying safe, and I will talk to you guys on Monday.